second video on section 6.1, we will continue with identifying the position function, the specific position function that we get from this given velocity function and this given initial position. So, if we find the antiderivative of the velocity function with respect to t, we're going to get the position function plus some constant c. So let's go ahead and do that with the specific velocity function that was given. So we want to find the antiderivative of the sine of t. And again, these are where you need to recall those antiderivatives pretty quickly from your work in Calc 1. And so the antiderivative of sine of t is negative cosine t plus c. So what we've just identified is that the position function is negative cosine t plus some constant c. But we need to be more specific than that. We need to find c. So one way that we learned that we can find c is that we can use this given information here, that s of 0 equals 1, or the initial position of the function is 1. So what I can do is I can plug 0 in for t, and then I can let s of t equal 1. And that will allow me to solve for c. So s of t is going to equal 1. I'm going to let t equal 0. And I'm going to evaluate that and isolate my constant. Again, use your unit circle facts pretty quickly. The cosine of 0 is 1. If I isolate c, I'm going to get 2. So my specific position function is negative cosine t plus 2. Okay, so that's the goal of this type of example. Now you may also be asked to continue on and find, well actually let me restate that. You may also be given the acceleration function and be asked to first find velocity using this method and then find position using that same method. So let me quickly just talk about method 2. There is, and by the way, they both accomplish the same thing. So it's really not necessary that you memorize both methods. If you're comfortable with this, then perhaps you can even just ignore the rest of the video. But if you're curious, we can just talk about it really quickly. Basically, there is a theorem in your textbook, Theorem 6.1, that gives you a formula, which is that s of t can be found by taking s of 0 plus the integral from 0 to t of v of x dx. Sorry about that notation there. But you can look the formula up in your textbook, and it just essentially is an explicit way of finding c without having to do it in 2 steps. So here we first had to find the antiderivative, and then we had to plug in s of t and t into our antiderivative to get the constant c. And in Theorem 6.1, all of that will happen in 1 step using this formula. So really, either method is acceptable, and it's completely up to you. All right, so that'll be it for section 6.1.